Now, today we supposed to discuss next part. It's this. Now, suppose people this way. In your oil science, you have learned about the resultant force of two forces. Resultant force. We discussed this lesson, right? Resultant force of two forces, right? People, this force is a vector, right? Now, suppose on a horizontal plane like this, right? On horizontal plane like this, suppose there is a small body on the horizontal plane. This is a small body. On this body, people, we apply two forces which are perpendicular to each other. One force we apply this direction. Suppose this force is 2 Newton force. One force is this 2 Newton force. The other force is perpendicular to it like this. Another, suppose 3 Newton force. The angle between these two forces mean people 90. Like this. If I draw that one again here. Right. So this is the body. Right. This is that 2 Newton force. And this is that 3 Newton force. This way. People, can somebody tell me, once we apply this way, these two forces, when we apply this way, these two forces, right? To what direction this body begins to move? To what direction this body begins to move? People, not along this direction. And also not along this direction. The body begins to move along a direction that is in between these two forces, along a direction like this. So this direction, suppose it begins to move. People, why? Why? The reason, people, we can explain like this. The whole effect made by these two forces on this body is along this direction. The whole effect made by these two forces is along this direction. That whole effect, people, is another force. That force is called as, people, the resultant force of these two forces. Understand? Okay. This direction only that resultant force acts. Resultant force. Therefore, people, the resultant force we define like this. Now, here this final effect made by these two forces on this object is this. Then these two forces together can give the single effect to this body along this direction by a force. And that force only the resultant force. Therefore, the resultant force is defined as how, people, instead of two or more forces to give the same effect to this object, what is the single force we can use? That single force we can use to give the same effect is called as the resultant force of that two or more forces. Okay. People, to find this resultant force, right? There's a method. This theory you will discuss people where in physics, and not only just studying this in physics lab people, there's a practical to prove proof of resultant force of two inclined forces. That way a practical is there in physics. When you do this practical in physics lab people, you will understand this truth of this theorem. What is the theorem? Resultant force of two forces. People, in this case, in finding the resultant force of these two forces, we can explain by that parallelogram law of forces we learn, right? Okay, people? Yeah. So it says like this. Now, in this case, the same thing I am going to use, right? Now, suppose this is our body. The 2 Newton force is here and 3 Newton force is here. This is 90. Okay. Now what we do is this. People, we first select a scale. That scale says us 1 centimeter long line segment represent 1 Newton force. That kind of scale people we use. Right. Now using that scale, what we do is this people. This 2 Newton force to represent, we have to draw a line segment according to the scale 2 centimeter long line segment. Suppose this is that 2 centimeter long line segment. Then according to this scale, this line segment represents that 2 Newton force. And this 3 Newton force is perpendicular to this 2 Newton force. Then we must draw another line segment perpendicular to this of length 3 centimeters long. Right? This is now 3 units. This is 2 units measured in centimeters. This is 90. Now we have people represented that two forces. Here we have by 2 adjacent line segments whose lengths are equal to the sizes of the forces. The angle between them is equal to 90 degrees, the angle between the two forces. Now taking these two sides as adjacent sides people, we construct this way a parallelogram. Really, since here we have 90-degree angle, this parallelogram going to be a rectangle. Now once we complete the rectangle like this, people, this is our rectangle now. Right? Now we join the diagonal connecting this and this vertices. Then we get a diagonal like this. Now this diagonal has a length. We measure this length that is coming in centimeters. Then we can very easily subject the scale that number of centimeters can easily be converted to number of newtons. Therefore, exactly the length we get in centimeters is equal to the newtons. So therefore, that length gives the size of the resultant force. Understand? Here we have. Okay. And this, measuring this angle, suppose theta. By measuring this angle, people, we can find the direction of that single resultant force. Then always that result is going away from this point, like this. Then this theta can be measured, because since this is a rectangle, if this is 3, this is also 3. Here 90. Then we can write tan theta. Tan theta 3/2. Because opposite divided by adjacent. Now using tan table, we can find this theta. Theta is tan inverse 3/2. That is how people we find the resultant force of these two forces. Right. This one people we again discuss under our applied maths syllabus under coplanar forces in detail we discuss. In this part, people, really, I want to tell you the resultant mean, instead of that two forces, what is the single force we can use to give the same effect? That force is called as a resultant force. People find in this way this resultant force is called as the vector sum of these two forces. Resultant force, resultant force is equivalent to, say, people find in the sum of the two forces, 2 newtons and 3 newtons. Vector sum, we say vector sum of 2 Newton and 3 Newton forces. People, therefore, remember, vector sum of two forces mean the resultant force of that two forces. The resultant force of that two forces. People, now, this we find in the resultant force, not only for forces, but this is true for any two vectors. You know, people, there are many vectors, infinitely many vectors around us. Now, for example, suppose when we consider velocity, people, velocity also a vector, right? Now, suppose when an aeroplane flies, people, we discussed this one also under our relative velocity lesson. When an aeroplane flies, people, really, now suppose in the air, when the aeroplane flying, people, this way, right, is the aeroplane, it will have a velocity, right, along its body. Understand? That velocity is generated by burning fuel through the engine of the aeroplane. Now, you know, this aeroplane is flying, people, in the medium of air. Air is a liquid, people. Understand? Air is a liquid. Right. So now, floating on the air particles only, now the aeroplane is flying. You will realize or learn this principle of how does this aeroplane fly on this air medium. You will learn this under physics, under Bernoulli principle. Understand? Now, when there is no wind blowing, this aeroplane can smoothly fly on this air particle to the direction of its velocity produced by the engine. Now, suppose, people, suddenly, while this aeroplane is flying smoothly like this, a wind is blowing to a particular direction. Suppose, for example, into the board direction, a wind is now blowing. This direction of motion of aeroplane is this. Into the board direction, perpendicular to that, suppose that wind is blowing. Then, people, the aeroplane is no longer flying as before to this direction, because it has now two velocities. First velocity is the previous velocity made by its engine. The other one is the velocity of the wind. Since the aeroplane now has two velocities, the aeroplane will be moving to what direction? To the direction of the resultant velocity. There, people, we have to find the resultant velocity of that two velocities. To that direction only, now the aeroplane moves. In finding that resultant velocity, people, again, this method here we can use. So therefore, people, to find the resultant of any two vectors, understand, we can use this method, the parallelogram law. The parallelogram law, we prove its truth by considering two forces. But that parallelogram law we prove in physics lab by doing the practical people can also be used for any two vectors, not only for two forces. There are many vectors now, as I told here. Velocity is a vector. Acceleration we can take as vector. Understand, people? So therefore, in finding the resultant vector of two inclined vectors, people, this parallelogram law can be used. Okay. Now, in this way, finding the resultant of two vectors, people, we say in the vector lesson as sum of two vectors, the sum of two vectors, or sometimes we use the vector sum. Vector sum of two vectors mean, people, there we are really finding what the resultant vector. Understand? So now here, people, we have another law in this vector lesson called as, people, triangle law of vector addition. Triangle law of vector addition. Understand? A triangle law of vector addition. That means if we need to add two vectors, how to add these two vectors? There's a method. Finally, people, by adding two vectors as our answer, we get another vector. What do you understand by that single vector? That single vector is the, people, resultant vector. That means instead of that two vectors, what is the single vector we can use? People, now here itself, you can get the idea about the triangle law of vector addition. Understand? So this is how we generate that. Now I told you these two forces by selecting this way a scale. First we represent by this way. Understand? By this way. Understood? Right? People, give me 1 second. Okay, now people, here, suppose in finding the resultant force of these forces 2 and 3, we of course first represented that 2 and 3 forces, subdue this scale by 2 line segments here. Thereafter, people, I constructed the rectangle. Then by this diagonal of the rectangle only, now we get what, people? The resultant force. Then see like this. Yeah. Now, this force I represent by this line segment, right? Okay. Here. Okay. Now, people, you know, this length and this length being equal. Why? This is the rectangle, no? The opposite sides of rectangle are equal in length. Then, without representing this 3 Newton force by this line segment, the same 3 Newton force I can represent by this line. Why? They are equal in length, parallel. And the same directed direction, if I put the direction, the arrowhead like this, that I am going to represent by this. We said what? The result is given by this, no, people? Then I erase this. Then this gives us what? 3 Newton force, this direction. Then when I consider here, people, earlier here we had the rectangle. Now what we have is a triangle. Then we have represented that 2 forces by the adjacent sides of a triangle in magnitude and direction. Then we notice this gives the resultant. So therefore, this is the third side of the same triangle. The third side will give the resultant force of that 2 forces, or the vector sum of that 2 forces. Then people, convert these thoughts to your own words. What is that? If we represent these two forces by the adjacent sides of a triangle in magnitude and direction. What is meant by in magnitude and direction? The length of the sides of the triangle give sizes of the forces. The directions give direction of the forces. That is the meaning of when we represent the two forces by two adjacent sides of a triangle in magnitude and direction, then their resultant, that means vector sum, will be given by the third side of the same triangle in magnitude and direction. Understand, people? This is called as the triangle law of vector addition. Understand? The triangle law of vector addition. So therefore, people, what is the triangle law of vector addition? People, we eliminate the word force from here. This triangle law of vector addition can be used for any two vectors. So therefore, instead of that word force, I am going to use the vector. What's that? When we need to add two vectors, we have to represent that two vectors in magnitude and direction by two adjacent sides of a triangle. Then by completing the triangle by the third side of the triangle, we get the vector sum of that two vectors in magnitude and direction. Understood, people? Right? Now suppose here we have two velocities. One velocity is this direction, another velocity is this direction. Suppose here 10 meters per second. Suppose this is 5 meters per second. Right? This angle is suppose 60. Now suppose we need to find the resultant velocity of these two velocities. That means when an aeroplane, while moving this direction with 10 meters per second, suppose inclined to its direction of motion, making an angle 60, a wind blows. Now we need to find to what direction, with which velocity now this aeroplane moves. That means we have to find, people, the resultant velocity of this and this. Understand? To find that resultant velocity, now we can use this triangle law of vector addition. Why? Triangle law of vector addition gives how to find the resultant vector. Then what we need to do, people, we have to first consider what? A triangle we have to first draw. Its one side gives 10 units to represent what? This 10 meters per second velocity. We have to draw that line segment parallel to this velocity 10 meters per second. From the ending point of that line segment, another line segment we have to draw parallel to what? This velocity, making an angle 60 like this. This is 60. This length is 5 units. This is 10 units. Then we have represented that two velocities by the adjacent sides of a triangle. People, then the resultant will be given by this side. Then you can measure this length. That length gives the resultant velocity. With that velocity only, to that direction only, the aeroplane now moves. Understand? So this is of course found by using the triangle law of vector addition. Understood? Right, people? So this is our next theory. Understand? So therefore, people, hereinafter, when we need to add two vectors, people, we have to use what? Triangle law of vector addition. Understand? Okay. Right. I think you could understand. Now we'll take down a brief note. Okay. Then we'll write the today heading as, people, the sum of two vectors. 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 Right now, people. Right. All right, all like this. Write down few sentences regarding this. Write down. For any two vectors, we can find a resultant vector. We can find a resultant vector. For example, when two forces act on a body, it is possible to find a single force which will give the same effect as that the two forces together given to the object. This single force is called as the resultant force of the two forces We will start from a new line. Write down. This resultant force is sometimes known as the vector sum of the two forces. The vector sum of the two forces. The vector sum of the two forces. Right. Start from new line, people, then write. Write down. In order to find the sum of two vectors, we use the triangle law of vector addition. The triangle law of vector addition. The triangle law of vector addition. Yeah, let's see, people. What is this triangle law of vector addition? Now write down, people, another subheading like this. The triangle law of vector addition. The triangle law of vector addition. The triangle law of vector addition is the next heading. Right. Asking a question, are we starting physical classes soon? People, government allowed us to start the physical classes November 16 onwards. You know the reason behind this. You know, all traveling restrictions now removed today. Then usually for this pandemic, you know, in order to spread, at least 2 weeks needed for this virus. They study this fortnight coming, 2 weeks, and if the situation is as before, right, that means at the present we can fortunately start 16th. And there are circulars they issued, they have specially mentioned those given what amendments can be changed. If the situation is worse than these people, again that date 16 will be postponed. So therefore nobody can say during this month we can start the physical classes. Though we can start the physical classes 16 November, people, the next 2 weeks also we do online classes, and I am going to start the physical classes December onwards. Fortunately, if we can continue this way furthermore. I don't think, people, I don't think that we will be able to start the physical classes to run smoothly as before. Again, another 1 or 2 times we have to go through physicals and come back to the online. So therefore, don't be hurry. In the month of November, we do the online, right? And we study the situation. And if the situation is okay, definitely December month onwards, we start the physical classes. And remember, this online class, we have till your AL examination. Okay, right. The triangle law of vector addition. Right. Now, what is the triangle law? When two vectors are represented by the adjacent sides of a triangle in magnitude and direction, then their sum will be given by the third side of the triangle in magnitude and direction. Understood? Okay. Write down that one. Write down like this. When two vectors are represented, when two vectors are represented, when two vectors are represented by two, TWO2, by two adjacent, by two adjacent sides of a triangle in magnitude and direction in magnitude and direction, then their sum, is given by the third side of the triangle, in magnitude and direction, in magnitude and direction. If suppose we have a vector like this, vector 1, this vector can be people what? A force, velocity, acceleration, or anything, right? And this is the next vector, vector 2. If we need to add them up, people, what we do? We represent vector 1 by the side of a triangle. Vector 2 by another side of the same triangle. They are adjacent sides now, right? This is the vector 1, this is vector 2. Then I denote this vector by AB, this vector by BC. Therefore, this vector 1 is represented by AB, vector 2 is represented by BC. Then their sum is given by what AC, like this. So therefore, how to write these people? Vector AB plus vector BC here. AB plus BC is equal to what? AC. This is called as the triangle law of vector addition. Right, people? Right. Okay. Then take these people. We need to add this vector and this vector. To add them up, what we do is this. So we add them up. This way. Understand? Yeah. Take down these people. Asking a question, how do we know the direction of resultant vector? That direction is coming by the experiment you do in the physics lab. If you are not sure here, you will realize that when you do that experiment. Okay. In the physics lab, really you can do this experiment. By that experiment, you yourself determine this is the direction. That will be very obvious one. Until we do this experiment, people, this issue might be coming. But people, you will decide yourself. Once you perform this experiment, you will decide, this is the direction. That direction is given people away from this point. Okay, right. Right, now you have an idea about what is the triangle law of forces, what use of this triangle of forces we have, what is really meant by the resultant vector, right? And the meaning of the resultant vector. So do experiments important else? People, experiment means practicals. Practicals are, people, very important. Don't miss the practicals. Practicals very important. People, by practical, there are lots of things to learn. How to set up a practical apparatus, right? How to keep them, how to tighten them, how to do the practical, how to take the readings. People, they, of course, very important. Why? The reason is, people, theoretically, practically, two parts, no, people. Theoretically, we can very easily explain something. We can very imagine that same thing. But people, once you bring this to practical, people, practical mean really not like thoughts. Physically, we try to do that. Once we try to do something physical, people, there are many obstacles. For a very simple example, people, we always discuss about smooth plane, smooth surface. People, smooth means what? Soft, no? That feeling we can very easily take, no? Soft. That means when you keep our palm sliding on that such smooth surface, people, very nice feeling we get. No frictional force coming while we are moving our palm this direction. That feeling we can, people, very easily imagine. We can see that mentally. People, if you try to form such smooth surface, wooden surface, for example, people, do you believe that we can form such smooth, 100% smooth surface? No, never. So that is why, people, we say the theory and practical people, when we implement this theory practically, people, there are more obstacles coming. Understand? That occasion, people, how to minimize this error? What should we do to minimize this error? This is a simple example I used. People, we have to use some extra strategies. Those things you can very easily plan once you do these practicals. Therefore, attend the practicals, people. Attend the practicals. By those only, people, some creative ideas are coming. There only you plan to minimize this error, to reach the theory, minimizing the error. How should we plan this practical to perform further? They are very important. Lack of practicals means, people, lack of performance, lack of results, inaccuracy will be increasing, people. That means what? From the standard value, your answer will deviate. Understand? Okay. So therefore, people, do the practicals. Maths means, people, engineering means practical related. Always these theories we apply for the practical situations. Right? So therefore, it is very important. It's very important. Right? Don't miss practical, people. Now you have more ways of studying these practicals. Once you go through YouTube, there are many practicals. But people, if you have the chance of doing that practicals yourself in the laboratory, people, it is very good opportunity. And even after entering the university, people, practical facilities are very high in universities. But most of the time, our students, even my university, study period, people, we didn't really use that opportunity well. Why? That is the bad age. After entering the lab, people, what we do with that apparatus and everything, we sometimes play. Why? That is, people, really the error in our education system. Right? We, of course, use this practical only for a short period of our study. More time allocated only for theories. So that is why, people, our country production, new thinking, new production, new things are not coming. Why? More theories, less practicals. Practical should be increased, people. Then only we use their practicals. That is the huge error in our education system. Right? No innovations, people. No new productions, no new machineries. Right? Though some people, they produce like this, the people, they analyze this, and who can, of course, give this to the future generation, they never give that. Why? They also have only the theory knowledge. By using that theory knowledge, they determine how can this guy produce this. He has no good education. That's how they think, people. Therefore, they do not recommend them. That is the error. So that is our particular issue in our education system. Now, when we consider Japan, people, small child, after their school, they contribute to what? Produce something. They produce small capacitors, transistors themselves. Then from that age only, people, they always participate to what? Something to produce. Thereby, people, everyone doing like this, mean, people, they will highly develop. But our countries, no, not like that. So therefore, as a good engineer, people, practical side is very important. You should be tactful how to convert your theory knowledge to what? Practical. If you can minimize this gap between theory knowledge and practical, people, there are a talented engineer will be formed into the nation. So that is very important. That's very important, right? Now, especially when we consider most of you are doing chemistry, no, people. in chemistry, though we have the compounds, everything, people, in the lab, some teachers are there. They can't, of course, form what? That mixing up to things, getting the same color and the temperature and so on, they can't get that. What is the reason? Sometimes once they mix up that amount, people, when they measure that amount, and that is, of course, not correct. Due to that, that result is not coming. Understand? What is the reality there, people? Once they mix up that one, they can't measure that accurately. What is the reason? They don't have practical. Huh? How many of you can feel a bottle is like this? Right. Another bottle is like this. Now this contains full of water. Now we have to fill that into this. How many of you can fill without wasting any drop of water from this bottle to this? Keep it like this. How many of you can do this? How many of you can? People, you can imagine that one. You can see that one because we have seen that before. But when you do that one, people, just today do. How many of you can do like that? Keeping a particular height between these two. People, at the beginning you can't, but once you practice that on people, they say, okay, instant, you can do that without wasting any drop. That is, people, practical experience. Very simple example I took here. Understand? How many of you bring a cup of tea, keeping to the top? Here, full tea there. Keeping this on a sauce like this, people. How many of you can keep this and bring without wasting, dropping any drop out of the lid? Is it impossible? No, possible, people. Then once you waste or actually once any drop of tea comes to the sauce, means what, people? You don't have that practice. That's not, people, practical. Simple examples. So therefore we have to improve that too. They are simple examples, right? Okay, there are lots of things to talk, people, about our education system, but what to do, people? What to do? No, right? Okay, now we can go to next part. Right. Now, people, next one we discuss about another important idea in these vectors. That is, people, position vector of a point. We'll come to that also. Thereafter, we can go to the questions relating to this triangle of vector addition. Okay, yeah. We will now write on this here. Next subheading, position vector. Position vector. Right. Now to explain this, I'll take this story. Now consider, people, Cartesian coordinate plane. You know, Cartesian coordinate plane is this, no? This is the x-axis, right? Perpendicular to this x-axis, we have the y-axis, right? Okay, this is 90 degree minus x-axis minus y-axis. This is the origin, no? Right? This is the origin. This is called as the origin. We will now suppose here we have a point P. Suppose its coordinate as 3, 4. Well, can you explain what is really meant by this 3 and 4? what is really meant by this 3 and 4? Yeah, 3 mean people, if we drop if we drop a perpendicular from this point P upon this x-axis, this length is 3 units. That is what this 3 says. Okay. When you drop a perpendicular from this P on y-axis, this is 4 units. That's the meaning of this 3 and 4. They are called as the coordinates of the point P. This is called as the x coordinate. This is called as the y coordinate. Right. People, now, suppose a person is at the point O. Person is at the point O here. Okay. This person need to go to the point P. Now, he doesn't know about the location of the point P, but he is given the 2 coordinates 3, 4. Then the person at the origin O first move this length along x-axis. Then from there, he moves 4 units parallel to y-axis from this point. Then you can very easily find the point P. Therefore, people, these 3, 4 coordinates describe the location of the point P on this plane relative to point O. People, why do we use the word relative to point O? Yeah, these 3 and 4 have been measured along the axis starting from the point O. This is 3, this is 4. That is why we say, people, relative to point O. So therefore, these 3, 4 coordinates describe the position of the point P relative to O. Position of point P relative to O. 3, 4 coordinates describe the position of point P relative to O. You can really understand that. People, can you suggest me another way of describing the location of point P relative to this O without using this way 3, 4 coordinates? What's that way if possible? People, I suggest another method to explain the position of the point P or relative to O like this. First I join this point O and this point P by a line, and I measure this length. That length we have, suppose that length we have. And I put this arrow here. Its direction I am going to measure by measuring this angle. Suppose that angle is 30 degrees or 60 degrees or 45 or whatever. That angle also we know. Right. Now, this same person at the point O, without giving this 3 and 4 coordinates, I am going to give him this length and this angle theta. Then, can you tell me, can this man find the point P as before, only using these two informations. Can, no, cannot. People? Can, no, cannot. Can. Can. Understand? Yeah. Now, people, if I take this point as O and this point as P, what is its length? Then OP. What is this angle? O to P angle. When you move from O to P, that angle is this with the x-axis. People, this length and this O to P direction, both when we include into one statement, what is that single statement which these two informations we can include in one? That is, people, OP vector, no? People, what are the two important things available in this OP vector? First one is OP length. You know this already. Why? At the very beginning of the definition of the vector, we learned this. What is next one, people? O to P direction. O to P direction. That both available in this single statement OP vector. So therefore, people, these two informations available in this OP. Then, people, since OP vector contains these two informations by which this person at O can easily find the location of P, this position of P, location of P, now clearly explained by this OP vector. Since this OP vector can clearly explain the location of point P relative to O, because both the direction and the length to the point P are measured from the point O. Therefore, OP vector explains the position of the point P. Therefore, this OP vector is called as the position vector of the point P. Position vector of the point P. Then you have an idea about what is really meant by position vector. People, what is really meant by a position vector? Relative to a vector origin O, we can explain a position, the position of a point P, by a vector which is starting from this vector origin O. That vector only, people, we define as the position vector. Understood? Understand? Right? Okay, so this is the simplest idea about the position vector, people, nothing else. Try to always understand, people, these things by matching your day-to-day life. Then, people, this theory is very easily you can absorb. Otherwise, if you think theory is different from our practical situation, means, people, this subject is going away from this. No, people, this subjects, these things are, people, very close to our personal life. The one who can match this well, people, will be the talented one. Right? In them only we say they know maths, they are talented. I think once you think like these, people, very easily all these things, concepts you can bring into your mind. So that is the, people, the seeds, then you have to, people, cultivate them thereafter. The fundamentals are those. Right? Okay. Now, then we'll write, people, this position vector. People, now, whenever we consider the position vector, you know, no use of these two axes X and Y, but still we need this O. Therefore, whenever we discuss the position vector, no longer we consider these two axes. Right? Therefore, when there are no axes, no coordinates. No axes, no coordinates. We need this origin. Right? This only we have when we speak about position vector. What is that, people? Vector origin O, like this. OP. This is all people we have. Therefore, relative to a vector origin O, the vector which can describe the position of another point in the same plane, that vector is called as the position vector of that point relative to the vector origin O. That is how people we understand this. Understood? Right now? Yeah. We'll take down this note, people. Now, people, in a physical class, now some of the students today absent, just watching this recording, they can really understand my explanation everywhere. But you know, once I give you the note, people, only 2-3 sentences. By reading only that 2-3 sentences, people, the idea I gave you by explaining, by talking, people, nobody can get. So that is one disadvantage of having the physical class. Suppose one day you absent, all right, you can't get that thoughts by getting the note, because my note, people, the thing I explain on the board, people, in here, I'm not going to give you in the note, because then it will be an essay. Therefore, it will be a short story. Right, people? Then once you take the time to write them all, people, no time to work out questions. And other thing is, people, maths means not the language, people, as we learn English or any other thing. It is a practical subject. Everything must be available in your mind. Then you might ask, why do we write, people? As human beings, we have some drawback. We can't keep remember everything, people. Once you feel this, the previous one, bottom things are going away. Right? In order to remind them easily, only we take a note. That note, therefore, should be the summary. By that, you should get advanced something. That's why we must write note in maths. People, we usually say we are not reading maths, we are working out questions. Right? But chemistry, people, you must do notes, you must write notes, because there are lots of theories. Right? Okay. So therefore, we minimize what the notes. So therefore, though we start physical classes, don't miss any class, people. Don't miss any class. Continuously join the class. Right? Once you miss, people, my 1 or 2 classes, I don't think that anybody can again catch that one. Right? So therefore, some students in 2022 also, people, they came the class here and there. Now we have come toward some complicated lessons without having the previous knowledge of the lessons, people. Now they can't manage them. They give up the class. What to do, people? I can't, of course, focus on them, because most talented students are with me. I have to consider them. So therefore, it's very important thing. Though you come join the physical class, never mind, I start the physical classes. Continuous attendance is very important throughout these 2 years. Understand, people? Okay, right. Will then people take down a brief note. So in the note, people, though we explain everything here, I give you what, people? Relative to a vector origin O, the vector which can explain the position of another point is called as the position vector of that point P. People, by that sentence, do you get all the things I explained here? No, no, never, people. If so, people, no need to come to this kind of class. You are well genius one. Okay, right? So you should be not here or some higher place. Right? So therefore, people, that's another advantage of this having online class, and we'll have this online class the physical class mixing up in order to avoid that drawback. Okay, right? So then we'll write, people, like this. Write down like this. Relative to a vector origin O, relative to a vector origin O, relative to a vector origin O, the position of another point, the position of another point on the same plane of point O. Can be explained, can be explained by a vector. This vector is called as the position vector of that point relative to the vector origin, relative to the vector origin. Write down people like this. Let the vector origin be O and the point be P. The point be P. Right, we will draw this diagram. Then you can write. First draw this one. Position vector of point P is given by OP vector. Write down this statement. Position vector of point P is given by OP vector. Right now, people. Yeah. Okay, now people, what is the position vector of this origin O? Yeah. When this point P is here, OP gives the position vector of point P. When this point P comes along this line, and when this P coincides with this O, then O and P both points now the same point. That occasion, this OP length will be equal to 0. Then by this OP, we must get position vector of point O. But this OP length is now 0. This vector is now null vector. Therefore, the position vector of the origin O is people null vector. Null vector. Understood? Okay. I'll write down like this. The position vector of the origin O is people 0 vector. Underline this, 0 vector, null vector, null vector, 0 vector, right? And the other thing is people, this is a usual practice. What's that? When we write the position vector OP, position vector of point P, it is OP, no? For our convenience, this OP whole vector is denoted by the simple letter of the second letter of this vector OP. What is the second letter? P. Its simple one is simple P. This way, we usually mark. It is not a rule. That's usual for practice, right? OP vector. So always people, we can't write this OP and put in the arrow like this. For our convenience, we use a single notation. In that notation, the letter here we use is the corresponding simple letter of the second letter in the left hand side. So if this is OA vector, people, this usual practice to denote this is simple A vector. OB vector, it is simple B vector. Suppose it is OQ vector, it is simple Q vector. This is a usual practice. Understand? We can use any other thing, but usually this is how we use that, right? Yeah. Now I am going to write people another thing like this. Now suppose we have 2 points, capital A and capital B, and the vector origin O is here. It's null vector, no? Position vector of the vector origin. Now I join this OA, and I join this OB, right? This OA vector is what? Position vector of capital A. OB vector is the position vector of capital B, right? Then we can write OA vector. We take people according to our usual practice. OA vector as simple A. What is this? Position vector of point capital A. Right. Or B vector, I'm going to take people simple B vector, position vector of point capital B, right? So then I take this as simple B vector. This is simple A vector. Then our next theory part is this. the vector starting from N and starting from A and ending at B, this vector, AB vector, I am going to find using the position vectors of the points A and B. Understood? Right. Write down like this, people. Now the subheading. To express a vector, by using the position vectors, of its ends, right, people? We'll write that's the heading. Now we'll write let simple A, underline simple A vector and simple B vector, underline simple B, wait, simple A vector and simple B vector, B, simple A vector and simple B vector, B, let simple A and simple B be the position vectors of the points capital A and capital B. The points capital A and capital B respectively relative to a vector origin O. Right, people. Now draw this diagram. Right, people. Short while ago, I told you that our start of our physical classes depends on the recorded patients in COVID during this 2 weeks now. People, now I received the newspaper article, right? Now you can see this one. Can you see this now? Right? Yeah. So this newspaper recording says සාමාන්‍ය පෙළ හා උසස් පෙළ ටියුෂන් ගැන තීන්දුව 16ට වාර්තා වන කොවිඩ් තත්ත්වය මතයි. Just now I told you, people. So therefore, this is the November 1st newspaper. Right, see here. So therefore, don't trust much on the physical classes yet. Okay. So therefore, people, I don't think that surely nobody can say that we can start the tuition classes. So therefore, people, don't hurry. Don't be hurried. Most of the students, I think, today absent class. Most of the classes, the student attendance is very poor because they are really, of course, thinking about to join the physical classes. Until we start, people, you have to continue this. Otherwise, you don't have the first and second both. You will miss. Will be, of course, finally huge issue if we do so. And so therefore, wait patiently till we can start the physical classes smoothly, right? Right, people, now we can write. Now I'm going to find this AB vector. People, now can you remind that triangle law of vector addition? Here A point, B point, and C point, AB, BC, and this is AC. Then we wrote, people, this AC vector is equal to AB vector plus BC vector. AB vector plus BC vector. Like that, people. You can write this AB vector like going from A to C. When you write AC vector, people, by using the triangle law of vector addition, how to write that? AC vector is equal to AB plus BC. That way of thinking of writing this AC vector, people, since we write A to C vector, we have to definitely start from A. And going along a path, you have to end at C. Then only path starting from A to reach the point C, the only path is, people, A, B, B, C. So therefore, we write A, C vector as AB vector plus BC vector. Understand? Like that, people, when you apply the triangle law of vector addition here to write A, B vector, we have to start from A and then come to O, and from there go to B. Then we get AB vector as A, O plus O, B. Understood? Then to write this AB vector, we apply the triangle law of vector addition to this triangle OAB. Right? And then we write like this. Write down by using the triangle law of vector addition to the triangle OAB. We can write, people, AB vector here, A to B vector is equal to what? A, O plus O, B. A, O plus O, B. People, this way, adding two vectors, we can interchange. That means, 2 plus 3 and 3 plus 2 being equal. No? The same thing we can apply here. I'll prove that. That law is called as the commutative law. Yeah. Then I can write this AB vector how? OB vector plus AO vector. Well, can you remember? I told you this letters we can interchange between them. Then the extra sign is coming, minus sign. So then we can write this as how, people? OB vector, this AO we can write as OA vector, and instead of this plus sign now we get minus. We all that, no, people, at the beginning. Then this is AB vector. What is, people, OB vector? OB vector is a Poisson vector of B relative to O. B minus OA vector is simply. Therefore, this position vector, AB vector, you can write using the position vectors like this. Then what is this, people? AB vector is therefore, what is B? Position vector of second letter in the left hand side. Position vector P dot B. Position vector of B second letter minus position vector of first letter. Understand? So therefore, when we write a given vector using the position vectors of its ends, people, how to write? In the left hand side, second letter corresponding position vector we must write on the right hand side first, minus left hand side first letter position vector. So this is another way of remembering this. Okay, right. Write down that too. Right. Yes, we learned now. Right. Now, people, the next one we must understand is, I told here without proof, when we need to add two vectors, we can, of course, interchange the order, or we can change the order of adding them up. That is to say, 2 plus 3 is equal to 3 plus 2. 2 and 3 are, people, non-real numbers, no, scalars, no. But same thing is true whenever we add vectors. Whenever we add vectors means, people, when we add two vectors, not only the magnitudes, but the signs also we have to consider. The direction also we have to consider. But in considering the addition of two scalars, 2 plus 3 and 3 plus 2, people, they are only we consider the sizes. The directions we don't consider with the scalars, because scalars have no directions. Okay, so therefore it is worth to check whether that same way we can apply for the vectors as well. Understand? Yeah. So therefore, people, when this way, suppose two vectors we have A and B, right? In this way, whenever we add these two vectors A and B, people, right? Suppose to the vector A, we add the vector B. The answer same answer we get adding vector A to the vector B this way. Then the order here change. So this rule is called as, people, commutative law. Commutative law of vector addition. Commutative law of vector addition. Vector addition is commutative. Commutative means, people, by changing the order of adding them, we can add. Right? So that is known as the commutative law of vector addition. We can very easily prove this, people. Right? Yeah. So then we'll write, people, next subheading as the commutative law of vector addition. The commutative law of vector addition. Right? Write down the commutative law of vector addition as your next subheading. The commutative law of vector addition. The commutative law of vector addition. The commutative law of vector addition. Right. People, we can write the commutative law. You can write let simple A vector, underline simple A, and simple B vector, underline simple B, B, any two vectors, be any two vectors. Then the commutative law explains people this relation. A vector plus B vector is equal to B vector plus A vector. This is the commutative law. This is the commutative law. We can very easily prove people like this. Proof we can do like this. Proof. People, I can take vector A by representing by this line segment. Okay. Vector B, I represent like this. Then I construct the parallelogram like this. We construct the parallelogram like this. When this is a parallelogram, people, this side is equal to this side is parallel to this. I put the arrowhead like this, then this vector will be equal to this vector. This side and this side are equal in length, they are parallel because this is a parallelogram. Then this vector also simple A, right? Yeah. So I'll take this one as A, B, C, D. Then AC vector I can write in two ways like this. People, once we apply triangle law of vector addition to the triangle ABC, I can write AC vector as how A, B plus B, C. The same AC vector I can write by using the triangle law of vector addition to the triangle ADC. The same vector AC now we have found in two ways. Then since the same vector we found in two ways, the two answers we got must be equal because both represent the same vector. Understand? Yeah. Then we can write by the triangle law of vector addition. By the triangle law of vector addition. By ABC triangle, we can write people AC vector is equal to AB vector plus BC vector. But you know this AB vector is simple A vector, BC vector is simple B vector. This is our AC vector. Let this be number one. Secondly, by ADC triangle, by ACD triangle, we can write again AC vector AD plus BC, AD plus DC vector. AC vector, thereby we can write AD vector is simple B vector, DC vector is simple A vector. This is number two. You can write, you can say people in number one and number two, the left hand sides, the same vector AC we have. Since the left hand sides are equal, you can say easily the right hand side must be equal, right? 1 equals 2. Therefore, we can write right hand side of 1 and right hand side of 2 must be equal. A plus B vector is equal to B plus A vector. So this is how we simply prove people the commutative law in vectors. Commutative law in vectors. Understood? Right. Take that, people. Start the proof. Okay, people. Take down this. Right. Okay. The next law is called as the associative law. Associative law. Under this associative law, people, associative law, right? Associative law of vector addition. Under this associative law of vector addition, people, we discuss this way something. Suppose there are three vectors. Suppose there are three vectors like A, B, C. A, B, and C be the three vectors. Now, people, we need to add these A, B, C vectors. When we need to add these A, B, C vectors, people, now you get an idea, a doubt or particular, particular kind of a doubtful situation, whether we add this first A and B, and to that answer we add C, or first we add B and C, to that answer we add A. People, whichever you do, people, the answer is correct. Understand? This one is what? Associative law. Right. And then we'll write the next one. The associative law of vector addition is the next subheading, people. The associative law of vector addition. The associative law of vector addition. Right. Write down like this. Let simple A, simple B, and simple C be three vectors. Then A vector plus B plus C is equal to A plus B plus C. This also we can very easily prove. We can very easily prove this. This is the proof. We'll see how to prove this, right? Well, I'll give you a particular hint to prove this. Just think to prove this. I'm going to take, people, this way the vector A, this way the vector B, this way the vector C. Right. Suppose this point is A, this point is B, this point is C, this point is D. Right? Then you can join like this. And you can join like this. And people, I'll prove this anyway. Just try to prove this associative law of vector addition, this one, by using this diagram. I'll give you 2 minutes. Using this diagram, people. Try to prove this. I think you can do this. Another one is this. The next line we need here. Okay, right. Try to prove this, people. I'll give you 2 minutes. I think you can do this. Let's see how to prove this now. People, now you can write this vector BD. This vector BD you can write by the triangle law of vector addition as BC vector plus CD vector, that is B plus C. Understood? Right now. Now you can write by BCD triangle, we can write BD vector is equal to BC vector plus CD vector. BC vector is, people, simple B vector. CD vector is simple C vector. Therefore, BD vector is B plus C. That means, people, this vector is B plus C. BD vector is B plus C vector. Right. Now we can write by ABD triangle. By ABD triangle. ABD triangle. You can write this AD vector. AD vector. AD vector is equal to AB plus BD. AB vector plus BD vector. But you know, people, AB vector is simple A vector. BD vector is B plus C vector. AD vector, then we can write AB vector is that simple A vector plus BD vector is, people, vector B plus vector C. Right, this is number 1. That means we obtain the left hand side. Okay, right. Now what I do is this. I'm going to find this AC vector. Right, AC vector. Right. AC vector by ABC triangle you can write. By ABC triangle you can write, people, AC vector is equal to AB vector plus BC vector. This is written by using the triangle law of vector addition. Triangle law of vector addition. AC vector is therefore AB vector is simple A vector, people. BC vector is simple B vector. This way we can write. So this is AC vector. Now A plus B. A plus B vector is this. People, here we put this bracket to say that A and B added together. Okay, right. Now you can write, people, by ACD triangle. By ACD triangle. By ACD triangle you can write ACD triangle is this. AD vector. AD vector is therefore AC vector plus CD vector. CD vector is equal to AC vector is, people, A plus B vector. Just now we found that A plus B, we write within bracket to give the idea that A and B have been added already, and CD is that C. Let us take this as number 2. Now, people, in this number 1 and number 2, the left hand side we have the same AD vector. So therefore the right hand side must be equal. Therefore you can write, therefore 1 equals to then we get A plus B plus C is equal to, people, A plus B plus C. This is how we prove this. This is how we prove the associative law of vector addition. right? Yeah. Complete the proof, people. This is how we prove that, people. Right. Right now, people, complete that. Yeah, completed this, people. Now, people, now another one result, we need to work out the questions in this vector lesson. That part also today I'm going to discuss. So then, people, next week onwards, we come to the questions in this vector lesson. This lesson is, people, remember, very easy lesson compared to all the lessons we know. This lesson is very easy lesson, right? First, we have to very carefully understand these theories, right? So next theory that we need to work out questions next day, people, the ratio theorem. That also I'm going to discuss now. Thereafter, people, do this lesson in the sense, try to understand this lesson, right? During this weekend, next week, before next week class, people, I put the tutorial, and sometimes I post a tutorial, right? And then we can work out the questions next week onwards. Okay, right? So the next theory part today, we discuss ratio theorem. Write down, people, heading as ratio theorem. Ratio theorem. Right. People, this ratio theorem, right? Another important one. We should know what is this ratio theorem. Right. Now, people, suppose we have a vector origin no here. Position vector is null vector no. And suppose we have this way 2 points with position vectors simple A and simple B. Right. A and B points have the position vector, simple A vector and simple B vector respectively. Now, suppose, people, on this line AB, we have a point C in between A and B. That point C divides this AB line in the ratio. Suppose mu is to lambda. You know the meaning of ratio. AC divided by CB. We get mu by lambda. This doesn't say that AC length is mu and CB length is lambda. Now, for example, people, suppose AC length is, suppose, 10 centimeters. CB length is 15 centimeters. Then, people, AC divided by CB mean, people, 10 divided by 15. But you know, this 10 and this 15 you can cancel down by what, people? 5. We get 2 and 3. Then this ratio AC divided by CB is, people, 2 by 3. Now you can see here AC is 2 means wrong, people. Actual length of AC is not 2. Actual length of CB is not 3. Ratio means, people, this fraction we simplify till we get the simplest fraction. That simplest fraction only, people, the ratio. Sometimes these figures can be the actual length. For example, now suppose AC 7 centimeters and this CB 13 centimeters. Then no longer this 7 and 13 we can divide. That occasion we get the actual length of AC and CB by these figures. Understood? So therefore, actual length and the ratio, now you can understand. If you have the ratio, to get the actual length, in that ratio, both the numerator and denominator should be multiplied by a particular value to get the actual length. Sometimes the value with which we have to multiply is 1, like a case like this. So therefore, now you can understand what is meant by this mu is to lambda. Simplified like this, the final simplest fraction we get is here we have mu is to lambda. Understood? Yeah. Now you can very clearly understand this OA means position vector of point capital A. It is simple A means, people, this is simple A. This is simple B. Understood? Now you can very clearly understand for this point C also, relative to this O, there is a position vector, right? So that means this OC. I'm going to take the position vector of this point C as simple C vector. This is therefore simple C. Now people, we try to find what this simple C vector, that is the position vector of the point C, using simple A vector, simple B vector, mu and lambda. Using AB, mu and lambda, I am going to find the simple C vector. Understood? So that result given the simple C vector is called as the ratio theorem. Ratio theorem. Understood? Right. And then people will write under this ratio theorem like this. Write down one sentence. Write down. Let the position vectors, of the points capital A and capital B, 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 right people? Simple A vector and simple B vector respectively. Write down. Suppose another point C, lies on AB in between A and B such that AC divided by CB equals mu divided by lambda. AC divided by CB equals mu divided by lambda. Then the position vector simple C of point capital C is given by simple C vector is equal to lambda times A plus mu times B divided by lambda plus mu. Okay, people. The position vector of the point capital C, that means this OC vector, people given by, remember the result. this side ratio multiplied by the other side position vector plus this side ratio figure multiplied the other side position vector is this numerator. Lambda A plus mu B is this numerator divided by sum of the ratios lambda plus mu. Understood, people? Right? Yeah. Now let's see how to prove this. Write down this and then come to proof, people. Come to the proof. Come to this proof. Proof. First, draw this, people. Diagram. Draw this diagram. Draw the diagram. Right. We'll see how to start this proof. Right. Right. We start the proof like this, people. Given that we are given, people, this, no, this ratio AC by CB equals mu by lambda. It is given that AC divided by CB is equal to mu divided by lambda. Now, people, you can use a cross multiplication to this end. Lambda times AC equals mu times CB. Mu into CB. People, this says AC times lambda, the whole length, is equal to CB times mu, the whole length. The left hand side length and the right hand side length being equal. That's very obvious result. Right. Now, come to the diagram, people. AC, CB. Here, AC means this same line segment, this line segment. CB means the same line segment AC produced. Then you can very clearly understand AC and CB are parallel. Okay. Now, this contains already two properties. What is the first property? Left hand side length and right hand side length being equal. Second one, by the diagram, AC, CB on the same line. Therefore, this left hand side line segment and the right hand side line segment are parallel to each other. Third one, A to C, when you move here, this arrow we have to put. C to B, the arrowhead, C to B. You can see when you move A to C along these letters and along these letters, A to C, C to B. People, same directed direction. Right? Then how many properties there we have, people? Left length equal to right length. Left hand side line segment, right hand side line segment are parallel because they lie on the same line. And what is the other one, people? Other one, A to C directed direction and C to B directed direction also being equal. So therefore, people, with these three qualities together, when we take, they are the three qualities we need for two vectors to be equal. Then these three qualities, people, how can we express in a single vector expression? These three, people, these three qualities we can express in a single vector expression as this way. Tell me whether I'm correct. I'm going to explain this all three conditions. Lambda AC vector is equal to mu CB vector. If we write like this, do we get that three properties by this vector equation? Yes, it is, people. Since these two vectors are equal, you know, left hand side length and the right hand side length being equal. What is left hand side length? AC times lambda. Right hand side length, CB times mu. This is coming. When two vectors are equal, people, the two line segments in the left and right must be parallel. AC should be parallel to CB. Well obvious by the diagram. AC and CB the same line, right? And the other one is what, people? A to C directed direction should be equal to C to B directed direction. That's also true. When you move from A to C, this is a direction. C to B, the same direction. So therefore, two properties available in the diagram, and the other one is given here. They together available in this. Now we can write after this, people, given this one and use in the diagram and use in the diagram. We may write what, people? We may write and use in the diagram, we may write lambda AC is equal to mu CB. Understood? Okay. People, now I can write. Can you remember in the morning we wrote AB vector using the position vector of B and A? We wrote, what is the method of writing that? Left hand side second letter, position vector we must write on the right hand side first, B, and then put minus here, first letter position vector. Like that, now you can write left hand side lambda times AC, second letter is C, its position vector is simple C, first letter is A, its position vector is simple A, put minus and simple A, is equal to here mu times B minus C. Now remove bracket. Lambda C vector minus lambda A vector equals mu B vector minus mu C vector. People, you know, we need what the vector C. We'll bring this vector C to one side. Yeah. We'll bring this to this side and this to right hand side. Then we get lambda C vector plus mu C vector is equal to, bring this lambda A to right hand side, lambda A vector plus mu B vector. Right. You can take, people, this C vector out from a bracket because it is common now. Right? It is common. Equals lambda A plus mu B vector. Now to subject this C vector, divide right hand side by lambda plus mu. Lambda plus mu. Then we get vector C. Therefore, vector C is equal to, divide this vector by this lambda plus mu. This is the, people, answer. This is the answer. Vector C is equal to lambda A plus mu B divided by lambda plus mu. Okay. People, we take another note by this. Right. First, write down this proof, people. Right on. We'll take down a note. People, now suppose this point C is the midpoint of this AB line. Point C lies exactly at the mid position of the point line AB. Then what can you say this mu and lambda? This length and this length being equal, no? So therefore, once we divide them, when the numerator and denominator equal, we can cancel down. We get 1:1. Then both mu and lambda become 1. Then we can find the position vector of the midpoint of a line. Understood? Right? Yeah. And then write down when the point C is the midpoint of AB, then lambda equals 1 and mu equals 1. Then you can substitute that lambda 1 mu 1 here. Then you can find the position vector at the midpoint. Then you can write the position vector of the midpoint of AB. Then the position vector of the midpoint of the line AB is given by, if I put lambda 1 here, mu 1 here, lambda 1 mu 1, what do you get? 1 times vector A plus 1 times vector B divided by 1 plus 1. What is that? A plus B by 2. So therefore, people, this gives us the position vector of the midpoint of a line. The position vector of the midpoint of a line can be written as at the position vectors of the ends of the line and divide by 2. Understand? This is how we take that. Right. People, then today I supposed to come to the end of this lesson. Right. Next week onwards, we do the questions. Right, people. Then 2 or 3 times revise this note. And if you need, you can watch this recording again. Right? You know how to take the recording. Right? So using that procedure, you have to take recording and watch the recording and take these theories thoroughly to your mind before we work out the questions next week onwards. Understood? Right. So then today we come to the end of the lesson. And next week we again meet Monday morning, 9 o'clock. Then people, nice week to everybody. Right? We meet next day. Bye.